Hello students, welcome back to All 4C Learning. This is session 47 and in continuation to carbonyl compounds reduction to alcohols, stereoselectivity of hydride reduction. Have a look here. I used to consider cyclohexanone, and regarding cyclohexane, when substituents are there, we know basic points very well, that is preferably bulky groups prefer to exist in equatorial rather than axial. In case of cyclohexane, chair conformations, bulky group prefers to exist in equatorial rather than axial, because in axial torsional strain will be there. In axial 1, 3, 5 interactions are there. So 1, 2, 3, 4, 5. Here at first carbon, whatever the group is there, third carbon, fifth carbon, all these three positions are towards upward direction. 2, 4, 6 are towards downward direction. So this is what we called 1, 3, 5 interactions. Because of 1, 3, 5 interactions also called torsional strain. Torsional strain means the strain which is obtained because of sigma bonded electrons. Strain because of sigma bond electrons, simply what we call torsional strain. So that will be exist. So before going to learn this concept, you should keep that point in your mind. So preferably equatorial more prefers, means if any group is there, it prefers to exist in equatorial rather than axial, right? So keep that point in your mind and let's come here. I used to consider cyclohexanone. Here alkyl group I mentioned as substituent which exists in equatorial position only. So fine. Now this one upon reduction. Here I am going to use two types of reducing agent. One is more hindered, another one is less hindered. So how do you make more hindrance? By substituting that hydrogen with alkyl groups like tritertiary isoamyl, diisoamyl, right? Secondary butyl. By using such a bulky alkyl groups, simply instead of writing all that alkyl groups, I used to mention as R. So here 3 R groups are there. Here R is not simple one, it is a more bulky one. Such bulky groups are 3 are there, and this boron is attached to one hydrogen. That means it is very clear, it is controlled reducing agent, right? Now let us see. So when we are using more hindered metal hydride, it prefers to approach in equatorial position. Its path is must and should be equatorial rather than axial. That is, hindered one cannot approach like this, it prefers to go like this. Or let us consider there are two paths. Path 1, it may approach like this. Path 2, it may approach like this. So this path is nothing but more hindered path because of more interaction, and this path is a less hindered path because of repulsions are less in between these hydrogens and this trialkyl borane derivative. Alright. So it is very clear, out of these two paths, this complex metal hydride prefers to approach in equatorial direction rather than axial direction. Because of in equatorial, hindrance is less, repulsions are less, whereas in axial, repulsions are more. Which repulsions are more? Torsional strain repulsions are more. Torsional strain. So already CH sigma bond electrons are there. With respect to this CH sigma bond electrons, this boron already negative charge and means electron rich, and its approach in this direction relatively we can say less. Fine. Now because of this B minus HR3 reagent approaches in equatorial direction, we are getting a transfer state here, and because of it approaching in this direction, this OH group moves like this. OH group will move like this. Now if you observe, this OH group has interaction with 3, 5 on hydrogens. 1, 2, 3, 4, 5, 6. So this OH group, first carbon OH group has interaction with third and fifth carbon containing hydrogens. So obviously here torsional strain is more, but this product only major product because of reagent approaches in equatorial position rather than axial position. Here you are getting axial alcohol, axial cyclohexanol as a major product we are getting in path 1, which is more favorable for approaching reagent, which is more favorable for reducing agent. Now let's come to path 2. Path 2, in this case what happened? Reducing agent approaches in more hindered direction. Because of more hindered direction and approaching one approaches here, this OH group comes like this, means that formed product consists OH group in equatorial position. That's what we called equatorial cyclohexanol. Equatorial cyclohexanol, in which OH group is in equatorial position. So here there is no change in the position of alkyl group. Here axial equatorial and equatorial, obviously these two products what we called diastereomers. These two products what we called diastereomers. Both axial equatorial. These two are diastereomers. That means substituted, alkyl substituted, where at fourth carbon. So 4-alkyl cyclohexanone upon reduction by using, say for example, diisoamyl borane or tri-tertiary butyl boron hydride, like that, means which consists much bulky alkyl groups. We are getting diastereomers of products, two products we are getting, of which one is major and one is minor. Here you need to stop 1 minute. In general, what we are saying, major product obviously from more stable carbocation and minor product obviously from less stable carbocation. In general, in carbocation concept, right or not? So what you are expecting here, it is major, means in general we are expecting this compound is a more stable compound, and this is minor, means this compound is a less stable compound. Is it true? In the beginning of this session I mentioned that if any substituent is present in axial position, then obviously torsional strands will be there. Because of that torsional strands, axial is less stable compared to equatorial. Now here in axial OH group is there, and OH group has interaction 135 interaction, that what we called torsional strand. Because of more torsional strand, this compound is less stable compound. This compound, out of these two isomers, this isomer is less stable, whereas this isomer here, both OH group and alkyl group both are in equatorial. Obviously what do you say? This one is more stable. So this one is more stable, fine. Is it a major product? No, it is a minor product. And this is less stable. Is it a minor product? No, it is a major product. Hope you got the point here. When we are reducing cyclohexanone derivative by using complex, sterically hindered complex metal hydride, then it prefers to approach, it means which one? This reagent, reducing agent prefers to approach in less hindered direction. That less hindered direction is nothing but equatorial direction. Resultant, the formed OH will comes to axial product. And in this case what happens? Second path, the attacking reagent if approaches along more hindered direction, means along axial direction, then the newly formed OH will come down here, that what we called equatorial. So here its approaching tendency is more. Further you are getting major product is less stable axial cyclohexanol, and because of more hindrance its approach is less. That's why you are getting more stable equatorial cyclohexanol as minor product. Major product, minor product. But here major product is less stable product and minor product is more stable product. And this type of reaction what we called steric approach control. This type of reaction what we called steric approach control. Here, which one controls? Which one controls complete reaction? Approaching of the reagent. Stereochemistry of approaching reagent. That what we called steric approach control reactions. That what we call steric approach control reactions. Now let us come here. Instead of more hindered complex metal hydride, let us use less hindered or normal sodium borohydride or lithium aluminum hydride or lithium borohydride. When we are using such normal, means without any hindrance, there is no alkyl substituted groups here. Alkyl groups are not substituted instead of hydrogens. Simply LiBH4, NaBH4, LiAlH4, such cases. Here, with respect to these hydrogens, strain or hindrance is less. Hindrance is less. In such a case, reagent has both possibilities. Here, what happened? Axial approach. This is what we called axial approach. And we are getting product, equatorial product. And this is what we called equatorial approach. Equatorial approach. In this case, this one is equatorial approach. And this approach is steric approach control. And this one is axial approach. Attacking reagent approaches in equatorial along axial position. So when approaches in axial, you are getting minor product, but that product is more stable product generally. Now let's come here. In this case, what happened? It axial approach, because of it is less hindered, because of it is not substituted, that's why hindrance is less, that's why it can approach axial. Of course, here also interactions are there, no doubt in that one. Here also interactions are there. And because of interaction, here which interactions here? 135 interactions. So interactions are there, and you are getting this complex like this, means transition state. Later this transition state convert into product. This product, in this product OH group comes to equatorial position. This is what we called major product. This is what we called major product. When it approaches in equatorial, and you are getting such type of complex, and you are getting axial product, I mentioned that minor, sir. There you mentioned equatorial is more suggestible because of attacking reagent is more hindered one. Okay. Here also equatorial, even though less hindered, so equatorial more na, means equatorial more prefers na. So you mentioned that equatorial less hindered, axial more hindered. Whether the attacking reagent is more bulky or less bulky, obviously it prefers to approach in a less hindered direction, isn't it? Now, what I explained in the first case, why not applicable in second case? In first case, you mentioned that equatorial approach is less hindered one. It can approach freely, fine. So the same concept, if we apply here, equatorial approach is less hindered, hence equatorial approach, then you are getting axial alcohol, then this product must be minor. Sir, maybe you write wrong, please correct that. You may think like that? No. Whatever I wrote here, that is correct. See, concept is, because here which one final product, which product you are getting, as we discussed that, this one is less stable. So, stability of a product or orientation of attacking reagent, these two are competitors. I am repeating once again. Stability of formed product and orientation of approach attacking reagent, reducing agent. Here, attacking reagent dominates formed product stability. Attacking reagent dominates. It looks its comfort. Whether the formed product is more stable or less stable, it is not necessary for me. Who is saying that? This attacking reagent. So this attacking reagent is prefers to approach in less hindered, whether the formed product is more stable or less stable. That's why this reaction what we called steric approach control. But in this case, attacking reagent can face that hindrance, attacking reagent can face the repulsions, and ultimately it level best to give more stable product as a major product. I am repeating. Attacking reducing agent prefers to face the repulsion in order to produce more stable product as a major product. In this case, attacking reagent cannot face any repulsions because of it is attached to more sterically hindered or more bulky alkyl group. That's why it cannot face any further repulsions. That's why it prefers to approach only in equatorial. But here it prefers to approach in axial rather than equatorial, because if it approaches in axial position, then here oxygen containing lone pairs are there. 3 lone pairs here, if you observe O minus and A plus, and here 2 lone pairs, here another one more lone pair. These lone pairs are projected far away from these 3 and 5 hydrogens. These lone pairs of oxygen projected far away from 3rd and 5th hydrogen. And further here you are getting product. This one is less hindered product. Formed product is less hindered. Formed product less torsional strain. Formed product is more stable product, and the formed product in such a direction, the formed product is major product. Of course, here it is facing a little repulsion. It's not a matter. But when it comes here, while approaching this reagent, here it faces less repulsions compared to earlier case. But formed product, if you observe, in transition state O minus is here. This containing electron pair will be like this, and this lone pair causes more interactions with these sigma bonds with respect to the CH and in 3rd and 5th. So 1, 3, 5 interactions are much more than what we called more torsional strain. This transition state is more torsional strain. Transition state has more torsional strain means its energy increases up to a certain extent. When which energy? Transition state energy increases. Transition state energy increases means what? So let us assume this is energy of reactants. Transition state energy increases means this is nothing but transition state. That means the energy difference in between transition state and energy of reactants, what we called the activation energy. Now you see, activation energy increases. Now let us apply again. If BH4 minus approaches in equatorial direction, in such a case what happens? It is facing less hindrance. And resultant formed transition state face more torsional strain. Because of it faces more torsional strain, obviously what happened? Here more energy, its energy what happened? Increases because of its energy. Whose energy? Transition state energy. When transition state energy increases, that means activation energy increases. When activation energy increases, reaction rate decreases. That means here the product what we are getting, that is minor product. Even though here when BH4 minus approaches in axial direction, initially it faces some repulsion, no doubt in that one. But formed transition state do not have that much energy. Because of it do not have that much energy, obviously activation energy is less. If activation energy is less, all the reactant molecules can freely convert into products. So this is the difference. Now once if you observe, complete this reaction mechanism, what we learn? If we are using a less hindered reducing agent, then more stable product is a major product. Less stable product is a minor product. More stable means equatorial OH and less stable means axial OH. Okay. Whereas when we are using more bulky reducing agent, in such a case we are getting a reverse to that. So less stable product we are getting major product, means axial cyclohexanol we are getting as a major product, and equatorial cyclohexanol we are getting as minor product. So in previous example, we considered hindrance of attacking reagent. By making more and more hindrance, In the attacking reagent, we are getting less stable product as a major product and more stable product as a minor product. Now, in order to get such a product, there is another alternative way. Come here. Cyclohexanone like that compounds. Here bicyclo compound, it is not cyclohexanone, bicyclo compound. Here upon reduction with NaBH4, this H minus approaches equatorial, resultant HCl OH group containing product we are getting 86%. When H minus approaches equatorial, because just now we learned that equatorial approach is more facilitated, less hindrance one. That's why H minus approaches in equatorial direction. Fine. Resultant we are getting product HCl OH group, that is 86% product, and equatorial OH 14%, that means minor product is equatorial and HCl is major product. Now I am going to change here. I am using more hindered bulky groups here, methyl groups, CH3 groups I am going to use. When we are using CH3, what happened here? In the complex, in this compound, hindrance increases, then product ratio reverse. HCl group, HCl position containing OH, 14% it comes, and the equatorial one becomes 86%. Same concept what we learned in previous example. The same here also, approaching H minus. Of course here this one is less hindered, but what we make here, we are going to increase hindrance here. Means there is no scope to attack in this direction, and it has to approach only in this direction, equatorial, and HCl is less. I am repeating once again. When we are using NaBH4, it is not more hindrance one, H minus. That H minus approaches preferably equatorial. So when it approaches equatorial, you are getting product OH HCl. Resultant you are getting HCl OH is 86%. Now, in order to prevent that equatorial approach, and in order to make more HCl approach, the attacking reagent H minus, we are going to increase hindrance. When we increase the hindrance, then what happens? It approaches HCl, resultant equatorial OH, we are getting major product. Right? Now, like this, one more, cyclohexene epoxide. This cyclohexene epoxide, tertiary butyl group I am going to place in equatorial position, and as you know epoxide here, assume that it is in like this, and the hydrogens, both the hydrogens are existing like this, means this one upon reaction with lithium aluminum hydride, in such a case H minus has to approach in HCl direction, H minus has to approach in HCl direction, and equatorial direction not possible because of epoxide ring is there. So this one is electron rich, oxygen is electron rich. Being oxygen is more electron rich, this H minus prefers to approach HCl position. Resultant we are getting this product as major product. Approach HCl and product also HCl. See there, approach equatorial, product is HCl. Here approach HCl and product also HCl. Now let's come here. In this case, H minus approaches like equatorial, and you are getting product also equatorial. H minus approaches in equatorial and product also equatorial. But equatorial approach is highly difficult. This one and this one both are same. This one and this one both are same. Here I shown that epoxide, just in our common language it is below the plane, it is above the plane. In general we are going to see like that, but these both are the same. Either way it is epoxide. Epoxide formation always is syn addition, cis epoxide only. So here both are same. So in this case what I am trying to explain here, only HCl approach is possible, equatorial approach is not possible. HCl approach is possible, equatorial approach is not possible, or we can say less possible. That means you are getting minor product this one, and you are getting major product. HCl approach, HCl alcohol major, equatorial approach, equatorial alcohol, that is minor. Let us see one more example here. epoxide only. From this epoxide, again, attacking reagent H minus. So, this H minus, instead of that, I am going to use a D4, LiAl D4, lithium aluminium deuteride, instead of hydride, deuteride. Now, I want to check where this D has to go. Now, this one, with respect to this epoxide, this carbon is more bulky and this carbon is less bulky. That means less hindrance. This D minus prefers to approach in this direction. As we learned in previous sessions, like bulky one, epoxide, bulky reagent attacks upon epoxide at less hindered carbon rather than more hindered carbon. Of course, here epoxide carbon do not have any substituents, but adjacent carbon possess methyl group. So anyway it causes, whether it is in axial or equital with respect to the epoxide, that is not criteria here. So here methyl group is there, and here there is no methyl, and here hydrogen only there. So compared to hydrogen, methyl causes more hindrance, that this D minus prefers to approach through less hindered direction. And obviously this epoxide in one side, and with respect to epoxide, this D minus in opposite side means exactly rear side attacking. Resultant, the newly formed OH and D minus, OH and D minus, you are getting anti means transposition. Irrespective of this methyl group, whether it is earlier wedge line or dashed line, that is not criteria here. Whatever it may be the line, it is not necessary, but it causes hindrance. It causes hindrance. Because of it causes hindrance, D minus approaching towards this carbon decreases, and D minus approaching towards this carbon increases. And so far, whatever the reactions we learned, like lithium aluminium hydride, sodium borohydride, all these are nothing but H minus, known as good reducing agents, right? So these reducing agents functioning, and similar to like Grignard reagents functioning is almost similar. Try to learn more number of mechanisms and more number of reactions.